going live. Is it done? It's live. Okay, we're live again. Hello everybody, welcome back to another coding live stream where we're gonna be making a game engine, or at least trying to. We've been failing pretty hard lately, especially last week was a bit weird. I found out last week that I was very ill prepared to take on the next steps, so I cut the live stream short, did some research. And hopefully today we're gonna try and redeem myself, and we're gonna continue working on the game engine. Specifically, we're gonna keep working on the render API, abstracting that, making sure that works perfectly fine for DirectX, but that the end user doesn't actually know we are using DirectX. So if we want, we can switch it out in the background in the future to something that's supported on like maybe like Vulkan or what is it, Metal, I think, yeah, or even OpenGL. I mean, if you can switch between all of those, that would be nice, but for now it's too interconnected with the actual engine. And if we get rid of that, I think we can move on to the next step where we can finally draw a cube, because now we still have one single triangle. I would show you, but unfortunately the game engine is in a broken state at the minute because I didn't finish it off last week. Okay, so before we actually get in, let me do the general YouTuber stuff. Let me actually share the live stream. No, you shouldn't be able to see that. Thank God. Oh, great. I love having this first window view so you can only see my webcam. So if I mess up with something, you actually don't know, which is great. Okay, there we go. That's shared. I did see somebody already in chat because I forgot to schedule the live stream in the weekend, so somebody was already very excited. Don't know if they'll join back in, but I mean, it's very cool to see people are excited for it. Okay, I think that's everything set up. Okay, that end is looking good. This end is also looking good. Oh, YouTube finally realized I'm streaming. That's great. Thank God for that. Okay, do I need to do anything else? I don't think so. Everything looks good on my monitor. Yeah, okay. So, before we go into the coding side of things, do I have anything on my topics checklist to talk about before we start? No, there's only one topic. As always, it's always there. It's how has your day been? Mine has been pretty good. As always, coming straight back from work, made some food, ate it, rushed eating it because I was late from work, and then got behind my PC and started setting this up. Okay. The weather is nice though. The weather is turning out to be pretty nice this week, which is great because we had rain all of last week and the week before. So I'm happy there's sunshine again. Either way, I think that is all good, and we should start talking about what we're actually gonna do today. So let's transition to the coding side of things. And then, yeah, this is my whole checklist of what to do. One major thing you might notice, it's right, it looks a little bit different. The colors look a little bit different, and that is because we are actually on the new version of Rider, which is 2026. It should be somewhere in, don't worry about it, just believe me, it's 2076. I was on 2025 before, and apparently they should have better CMake support, and that's actually what I want to try out first before we get into any of this to-do list. Basically, all of my projects basically have like a target folder where they are supposed to be used in. So this is for render API, I think Engine Core also has one. Yeah, see, they all have a target properties folder. And I want to see if we can actually get that inside here. And I think it's all set up. The only thing I forgot to do, so it might have actually already worked in 2025, is if I open this CMake list, I should set a property here. I should set a global property here. Do I have any setup here somewhere? No, I can do it for environment. So set global, I think it is, and then use folders to on. Do I have that correct? I did open it up. Oh, there it is. Okay, yeah, I do have. So it's use folders, it's a global property. I think at least it's specified it here. If we go to folder, Yeah, global property use folder must be set to true, otherwise folder property is just ignored. So set folder, it's not on, it's true. And that should work. So let's actually recompile. Where's my zero check? This one. Recompile. Rebuild selected projects. I don't think I actually need to rebuild anymore. That was very quick. I don't think that did anything. Huh? This might be one of the files. Wait, did it check? We're not actually make because generate timestamp is out of date. Yeah, so it did rerun, but it didn't add the... Oh man, I was hoping this would work. Shoot. Okay, let's do some general quick debugging to see if I actually got it correct. Because it might be like set property or something. Ah, there we go. How to organize my things. Source group, I don't need that. Set property, maybe? Yeah, it's set property global. Okay, so let's just copy this. See if that works. Set property global property. That makes more sense, right? I should probably have looked this one up. Okay. And then rebuild. We have folders. Oh, that's so much better. So now I know this is the application. This is my engine. Oh, that's so much better. And then we have the predefined targets. So if we need to rebuild, actually, one other thing I want to check. I don't know if we will be able to check it, but basically, if I add a file, which I actually need to do in a second, so you can test that in a second, I should be able to just build zero check and it should update. That didn't work on Rider 25. So let's see, because the first thing we need to do is use an interface for a render API. What I figured out last time is that a render API will need some specific DirectX 12 members. So actually we don't want any of them. All the members that we want to have will need to be only abstracted things, like an abstracted window, or I have another one somewhere, an abstracted, where's the command list? Yeah, the render command list. These are already abstracted. But the command queue, this will be specific for DirectX 12. So we need some kind of interface to work with. That's what we're going to set up first. And to do that, inside our CMake, we are also going to add a render API.h in DirectX 12. So we're going to add it here. We're also going to add it on disk. So we have engine render API in this one. Just got to copy this for now. It will not compile, but nothing compiles anyway at the moment. Boom, like that. Yes, I want to change it. Okay, that's that. That's all of that set up. I don't need to close this. So now we can try if we can just right click and build selected projects. See, this is still broken. It should rebuild because my CMake changed. So I don't like that because this build selected projects is so far. But it does rebuild. Okay. And that should have added the render API.cpp. Okay. This all can be deleted. And this can basically become what's in here. So let's copy this over inside here. And then what we're gonna do, this is awful. Why do you automatically close? Folding. I'm gonna twiddle with settings a lot today as well because it's new. So let's actually file and let's find folding. Cold folding, fold by default. No, I don't want any file headers or anything folded by default. Save. Whew, okay, that saved me a lot of trouble. Okay, so this is actually correct. So let's clean up. We have a copy here, so let's clean up our render API itself. We don't want any of this in here. We don't want this in here either. We can live with the defines and these two. So let's actually group those together. Let's clean up a little bit here. There we go. That's a little bit nicer. And that's gonna give us a bunch of errors here, right? So throwaway failed. We don't need that. The private members, these, don't need those. We don't need these either. We might make abstractions for them later on. We don't need this. The render command list we do have. That one is already abstracted. These can all go as well. We will abstract all of these eventually. But yeah, these are the only two we have at the moment. So that's actually nice and cleaned up. And then inside here, what we're gonna do is we're gonna mark this as virtual. If I can type it correctly. And then initialize. This is gonna be crazy, right? Because we are gonna initialize load assets doesn't make sense anymore. So let's remove that one, I guess. No, create from the command list, that makes sense to have, but it's gonna be blank here. Yeah, I know it's implemented, don't worry, we'll clean it up. Bind mesh does not make sense. Render kind of makes sense for now. These can all go as well, so we don't have any private functions anymore. We have that, we have initialize, we have load assets for now. Render is also not implemented. Although we might implement this. We can't, no we don't, we can't. Okay. And node shader we also can't implement. Okay, so load assets we actually don't need on here either, so let's remove that. And initialize I'm not so sure on. Okay, so what did I do here? I made an interface. So actually we can remove these as well, because they don't matter for this. There we go. It's a lot simpler of a file, isn't it? Okay, what this did is we made this file, and then we're going to implement it here. So what we're going to do is instead of having all of this, we're going to have a DirectX 12 render API. Let's see if we can actually... okay, that was the right naming convention, I wasn't sure. And what we're going to do with that is we're going to mark it as final, and then we're going to publicly inherit from the normal HB render API, not the render command list. There we go. And we're gonna include it. And that's this. Okay, it's nice and cool. Let's also group these together because that's cleaner. That's too much. And then yeah, that's fine. So this should be delete, copy, and default move. Actually, can we? I do want to. Okay, we're gonna fiddle with some more settings because we don't have colors for macros. So let's go to color scheme, C++. Let's find macros. Can we search it here? Apparently not. Great. Assembler braces. Assembler maybe? Oh. Can we click on something? This. Preprocessor macros. Preprocessor macros, we are gonna do... Can we... Why is it... There we go. That's more like it. Yes, this is a good color. And then that's fine. Global variables can be white, but can we make them bold maybe? That's also a global cont. Nah, that's fine, safe. Whew. There we go. Okay, we got back our... Oh, that's funny. So we need to... We have all of this. We can't have a command list in here, actually. And we can't have the window because they are already in our base render API. Right? So no need to do it. What the hell are you? Change visibility, never show. Don't do that to me. Oh boy. gonna be a lot of me yelling at things apparently. Okay, this. So it's never gonna be render API, so let's copy this. Do that. Render API. Oh, what? Okay, that's fine. And we're gonna include DirectX 12 render API. Right, and then this also needs to be on here. And we do need this. There we go. And yeah, that's sorted correctly now. All of this, stupid. I still want a way to figure this out properly, but we don't have it yet. Alright, so render API, we have initialized. Let's just rename all of these for now, and then we'll worry about the actual solving of codes later. These will not work because they don't exist. Oh, and command list is not. Oh yeah, we need to make them protected. So, if you don't know about classes and inheritance, basically you have three types of access. You have public and private, and then you have protected. Public means anybody can access it, which is this. Private means nobody can access it. And protected means something that inherits from you. So say we have an inherit from a render API. Normally if it's public, we can access. Private, we can't. If it's protected, we can also access it as long as we inherit from it. So that means that instead of having private here, I should have protected, so that we can use all of this. I don't know about the frame count. Do we might want to put the frame count in there. Does she want to complain now because we have that detected twice? Anyway, okay. And this is an overwrite. This is... Oh no, this was just not implemented. That makes sense. What's the issue here? What are you complaining about? Function hides a non-virtual function from base class. Oh, I should make them virtual. Yeah, even if they're that, we need to virtual. Yeah. Copy that. Paste it in here, paste it in here. Not sure about the initialize though. Still not sure. So I'll leave that for now. And then we do override here. Not on initialize, I just said not on initialize. Override. I'm gonna override this one. The only reason the override keyword exists is for your own sanity. Basically it means that you're trying to make something that does not exist or something similar. Alright, so here we should call also render API. There we go. Even though it's not doing anything, it might in the future, so I want to make sure that's correct. Members are not initialized by this constructor. That's something to worry about later on. What the hell are you? Go away! Don't have all inlay hits. I don't want inlay hits. I don't like them. Whew. Oh, welcome back! I saw you joined earlier. Yeah, sorry, I wasn't streaming yet. I just made the stream. How to become a crack dev like you? I'm not a crack dev at all. I know the basics, like the tip of the iceberg, but I'm willing to learn, and that's the main reason. Preprocessor code can be more if def. Oh yeah, it's just if def, isn't it? Why make it difficult? That is correct. Thanks for the suggestion, IntelliSense. That's actually a good one. Also, I don't like this. Okay. Do I need to check anything here? Oh yeah, we still have all the errors to fix, I guess. But are there any functions that we implement in render API that we shouldn't? Yes, the initialize. Wait. we can't have these all have to be virtual. We can't have any functions implemented here. Okay, let's do it like that. That makes more sense. This is a pure virtual interface. We have to override every single thing here because we are implementing from it. So you as well, override, there we go. You should be working. Overriding the structure but does not have an override keyword specified. Well, you actually don't. Shut up. Okay. I think we're back at the state now that it was broken in. Yeah, we got all of these issues to figure out, but I also think inside our application, we also have the main function. That one works. Application maybe still is broken because, yeah, vertex, we don't have this yet. And we don't have load assets. How do we create a render API? Oh, we just initialize it, but we don't know. Do we know that this is a... No, it's a... Okay, so it has to be a unique pointer. Okay, so we need to fix that as well. I don't necessarily like this. And we might work around that. I have a solution for it, maybe, but not now. Actually, it's kind of the same solution, isn't it? Yeah, it is. It's fine. This is fine, but this means that we actually need to make it now. So we can't just do that. We also gonna have to do create render API, and it will take a window. And then, oh no, you can just do that, and then this will still be the same thing, right? And then copy that into this. Whew. It's also not that, but that, because it's a pointer now. We'll make sure it all works in the end. Okay. Yeah, we will worry about that later on. The render function should still be implemented. The load asset's not, but we'll figure it out. This though, we need to work about this. How did I implement? Where's that? Create application help. Where's the engine core? Okay, that makes kind of sense. Create render API. This should be at the top one. And this should just be empty, and that returns an HP render API. So we also need to do render API here, like so, and then we're gonna go to this file, and then we're gonna implement it exactly the same as this way, but create render API. We don't need any things here. Render API, copy, paste it here, that, and then we also need to do render API. Whew. That's some speed running changes here, but I think we should now have HP render, create render API. Okay, so this is all fixed now. Load assets doesn't exist, so yoink. Let's just ignore that for now. Actually, no, let's make it exist for now. Okay, so load assets, we will get rid of it function. Are you following any guide or just building it on? This is just me building it on my own. I do have a degree in game development, so I know a little bit of what I'm doing, but there's a lot of stuff I'm just winging. And this is also going to be override. Luckily, I do have a decent understanding of how C++ works, which makes all the things a lot easier. So load assets. Hello, welcome to the stream. Making a game engine from scratch. Currently it's a very broken state, otherwise it would show off what we already have, even though it's not much. It's something. Okay, so the load assets fixed now. There we go. So this, we still need to set up the triangle. Where am I? Oh, I'm not using this yet. Okay, so let's just comment it out for now. This fixed. I think only thing left to fix is the actual render API file itself. So that one, no, this one is, why are you complaining? I don't have this function anymore. It's not implemented. Okay, let's remove that then. Where am I from? I'm from Belgium. Okay, so this is all the red we still have left, I think. Yeah, and that's with command list, which is where I left off last time. Before we dive into that, user interface, boom, we can remove that. So now I want to introduce the render command list as, well, basically how do we call it? What this does actually is it collects all of our render commands in a list. So basically we will ask it to draw a cube or draw a triangle. That's a better way of saying it. Draw a triangle, and we'll put that in the list. Then you ask it another triangle, put that in the list, and so on until you have a full list of things. And once you're ready with all your render commands, so basically once you fully drawn out your scene, you're gonna send this whole list in one go to the GPU, and it will hopefully render your scene for you. So I already started with this last time, but I got absolutely wrecked with how much I actually needed to do, and I was underprepared, so that's why I left it out for this week. So what do we need to do? Basically, I did say we can create all of these classes first. We're not going to do that. We're going to make the command list first. So what we're going to do is we're just going to do this right here. And we're going to create a command list. The only issue with this is it's going to be only available on the DirectX 12 command list for now. You started learning Python? It's a very good skill to have. Can I do that? It's gonna be... I hate myself for making this platform independent. Well, in the future. It's so much more annoying to do things. Because basically, everything will go through this render command list. So, how are we actually gonna do it? Are we gonna do it by... Yeah, we're gonna go to submit through the render command list, right? So we actually, what we do is we ask the render API to create a command list, I think. So we can do command list equals create command list. And this is actually not implemented. Did I see that correct? Create render command list. Okay. Go back. Go back. Oh, I should set these shortcuts on my thing. Okay. There, and this will return us a unique pointer of our render command list. So auto command list. Where am I gonna save this thing? Also a good question. I think that's why I wanted the render target. For now, we're gonna just save it in the application. So we're gonna make a unique pointer here of render command list. Render command list. Also gonna have to do the same here. There we go. Cancel. There we go. I like this. I don't like this. Silent. I don't want this. Whew. Give some piece of advice. What do you want advice for learning Python? It's gonna be if you just ask for random advice. I mean, coding advice I can give you, but you'll need a little bit more, be a little bit more specific. Okay. So we actually make the render command list here. There we go. Which is unique pointer, which is correct, and then we can add things to this render command list. It's gonna be our next step. So basically everything we actually do is it in render? Yes. In this render, we don't want to do, basically we don't want to call render. That's basically it. So we're going to remove that. And then go back to render API. And then we're going to Now we're not going to remove it from this one yet, but we can remove it from this one. Okay. In the era of AI, you feel what you're doing? I've had this question asked a lot. I mean, really like a lot of times. But basically what it comes down to is how you use AI, I would say. That's one thing. But also, for coding, it's not at a point where an application can be fully generated from AI yet. It makes too many mistakes. And specifically in the game development sector, it needs to be such optimized code because it needs to do a billion calculations at once. AI is not good at that. AI is good at pattern recognition. But actually making like a unique piece of software, it's not good at. It can help you understand things. It can help you find bugs, find solutions, right? Find people with similar problems, but it can't help you actually design your 100% what you're gonna do. It can give you the broad lines, but not the actual implementation. So as part of what I'm doing, I'm not fearful of it at the moment. I've used like a little bit of AI to see how good it was at doing things like this. It's not good. It makes too many mistakes. So we have this render function. We don't want to do any of this. Well, we actually do want to do it, but not like this way. We want to do... Actually, I'm gonna bring back the render function. But it's not gonna be used in the way that you think. So we're gonna bring that back. We're going about the application. Before we do that, we need to do in the render API .submit render command lists. So we're gonna implement that now. So private. Why is that private? Oh, that's wrong one. This one. Rem and then submit. And it's gonna take a const reference to a ls unique pointer. ls, not lshp. Unique pointer of hp render command list. So what I'm doing now is making a submit function so we can submit the render command list, the thing I was talking about before, and send it to the render API saying like, hey, this is what we're gonna render. Render command list. Okay. So in our render API, we're gonna make that same function. I should actually copy it over. Copy that one into this one. Boop. Let's actually put that separate as well. Then submit. It's not virtual, but we're gonna do overwrite. What do I do for a living? I do this. I program for a living. I help make games for a living. I'm a game engine developer. So basically, what I'm doing now is my day-to-day, but this is a little bit better. That was weird. Okay. Now we're gonna make a submit function. Oh, thank God I don't have to write that. So it takes that, and then we're gonna do exactly that. Wait, am I gonna do that? No, I want to make that list, right? So, ooh, this is gonna be tricky. Wait, no, we're always gonna only have one command list, I think. So, yeah, so we have submit, which is actually the wrong submit. God damn it. Put that in front of there. That's more correct. But you have no member submit. I just put it there. Ugh. I used to autocomplete. See, this is why AI is bad. Oh, there's another question. Well, what was your first coding language? First one I tried was, I had this question before as well. First one I tried was C++, gave up very quickly. I got to multi-dimensional arrays and then I was like, oh my god, this is too much for my brain. And then it took me a couple of years before actually getting back into it. Saw the basic of C++ again, but then switched over to actually web development, so HTML, C++, CSS, and JavaScript. And then after that, I moved on to Java, and from Java, I got back into C++, C#, and that's how we end up here. I do like C++ the most, just because you have more control than in most languages. But it also makes it a lot more dangerous. Okay, so we have a submit, we have an can we just, because we have this, right? This is actually command list to submit, I'll call it. Right, and it's not going to be a unique pointer, it's going to be an actual pointer. Right here, yeah, okay. And then this is temporary until we have our command Q wrapper, which will do all of this for us. So we will only have to submit and that one will track it. But one step at a time, right? Okay, so we got that, and then we're gonna set command list to submit command list to, yes, this exact thing. Oh, and I can't do that. Ooh, that's interesting. So we're actually gonna have to make it a const command list. Oh, wait, it's in this one. Yeah, this one doesn't even need a const. Yeah, this is temporary. Purely, actually, it doesn't need to be in here. Purely temporary. In here. And we can actually say it's a direct 12 command lists. But actually I don't want to do that, because then it would give me too much control. Okay, so put that in here. Puts that in here. Yeah, that's temporary. Are you still complaining? What are you complaining about now? Can I convert from const unique pointer to unique pointer when the command list function is missing const qualifier? Did I make it a unique pointer again? Oh, const. There we go. Is still complaining? Yeesh. Okay, it's gonna be more tricky then. Oh, I can just do that, I think. Which doesn't pass the ownership because it's by reference. That works. Yeah, that makes more sense. And then inside here, we actually don't want all of these const things because that doesn't make sense anyway. And then this should work now. Okay. How many times to learn all of this stuff? You mean how long it took me to learn all of this? Multiple years. To get decent at a programming language, you can do in a couple of months. To get actually to a stage where you can do it professionally, I would suggest actually following some kind of education for it. Because they know what you're gonna see in the industry, how it's gonna be used. So populate command queue we don't need to do, because that's this is gonna move from this to somewhere else. But then our submit, where's our submit? We did this, and then in here we're actually gonna say that, to submit. Right. Dot. Oh, and this one needs to be the actual command list. So we're gonna do get raw. Or get list. Right. So we're gonna do wait, that's gonna be tricky. I forgot we actually need to get the actual underlying pointer for this. Oh boy. What we could do, I think that's actually fine, since it's here. We know it's gonna be DirectX 12 render command list. Right, now we can copy that, put it in here. Oh, we actually don't need this anymore, great. We can put it in here, let's put that there, class. There we go, that should work. And then inside this one, no, inside this one. How old am I? 26. Get command list, that will be fine. I'm pretty sure this will not work now, so we'll need to static cast it. Set it to the correct type, which was an HP render DirectX 12 render command list. RCL. Oops. So I need to do that first, and then this RCL and get. Boop. There we go. Why is a static? Oh, it's a pointer. There we go. Got all that, and then we can put on our DirectX 12 one. We can have you pointer get command lists. That's not an override, and just gonna return command list to get. Get raw. There we go. That's that done. Don't think I need that actually. Okay, that's all done. So now, what do we still need? We have here. Do we actually use this here? I don't think so, right? No, we don't. So we don't need to create a command list. Oh yeah, load assets. We're gonna remove all of these things. So how, okay, you want to have my learning journey included with ages? Well, let's put it this way. At 12, I tried starting off with C++, didn't work, let it cool off for about 6 years, and then at like, nah, not 6 years, around 16, 17-ish, I picked it up again. And then from there, it was all pretty quick. So by 18, I started studying for engineering, so I got a full education in programming languages. So yeah, I picked up speed there. But I would say from 18 onwards, I've been pretty involved with programming language and learning them. Okay, so we still have all of this to figure out. Command list to reset. Okay. What's that? That's dangerous. That shouldn't work. That's wrong. Okay, so in our application we have a render. Okay, this is where we're gonna do fill render queue. First thing we need to do is render command list, reset it. And then this is where it gets tricky. We're gonna submit it, and then we're gonna render. The render will do whatever it does, right? And we're done. But we need to do this, yeah. And this is all gonna be all of this code. All of this crap needs to be in there. And we need to do that in a little bit more optimized way. So. No. That is too personal. Press the wrong button. Okay. That's already one of the issues fixed. Oh, we still need to call finish on it? I think so. So we're gonna do render command list dot finish. Okay. What does finish do actually? I have it implemented. Oh, it closes it. Okay. That's all. So now our next one. So we don't need to do this anymore either. So the reset and this don't need to do. Populate command buffer. Let's actually already remove it from this one, because we're not gonna do it. Also load assets. We won't. We will move this at some point. Populate command buffer. We're gonna not do that. Okay. The next Godot, it's far from there, but that's basically the goal, yeah. It's time to, well, the goal is to make a game engine and make a game with it. So yeah, basically that's it. Okay, so these are gonna be tricky. So we're gonna do this first, right? Okay. One thing we need to do though is on the render command list, we need to actually put the render API. We need to put a reference to the render API, because that's how we're gonna do everything. So basically how it is gonna work is we're gonna create some couple of resources from the render API, which will be how we interact with everything else. Those include the render command list, which will contain all of our drawing commands, probably a render target, and we will probably also like set up render pauses and things in the future. But we will interact, well, the game will interact with those and not with the render API directly. So when we create a render command list, we're also gonna set, so we're gonna create a unique pointer, and before we return it, so I'm actually gonna yoink this first. So we're gonna make this. Then we're gonna return this one eventually, but first we're gonna set up something, I think. Actually, no, we don't need to. No, we don't need to. We can just put it in the can we put it in this constructor? Yeah, we can just put it in the constructor call. Yeah. So, inside this one, we are gonna have a direct x12 underscore render API. This one. Wait. What is it? Control down, control up? No, just this one. Then we're gonna add a forward declaration for this, because we're gonna make a pointer out of it. Okay, I don't like that. I like my forward declarations to be separate from my actual implementation. Boop, boop, boop. There we go. Done. What's the question? I don't really know how Aegis works, but is there like any way like having inbuilt Proton W support and pop of hard? I mean, this is very early stages. The only thing I have at the moment is just a triangle. But yeah, I mean, the goals are very, very far. Okay, so then we're gonna set the render API to null pointer because I have not initialized it. And it's gonna be the first thing we pass here. It's just HB comma there already. And then why does it always just do that? API and then render API pointer. Thank you very much. With that, paste it in here. Not render command list. Render API. There we go. There we go. What are you building now? I'm building a game engine. But specifically, if you ask specifically, I am building the, how would call it, the graphics pipeline. So basically how we are gonna be rendering things to the screen. Okay, and then I also need to put this in the actual file here, which is here. There we go, and then inside the render API, I don't need this anymore, so I can just return. I was being overzealous. I don't need this. Don't need that extra white line. I can put that here, and then we're gonna be adding this pointer in here. Yes. Do you have a cat to become a mascot? How big internet projects need a cat? I don't have a cat. I don't have any pets. It's a good idea to have a mascot, but I mean, I'm just starting off at this point. Ooh. Why not take the help of AI to write code? Because you need to spend time actually understanding the code. And if AI writes it, first of all, you probably don't understand what it's doing. And secondly, for this kind of thing, for this low level thing where it has to be optimized, it doesn't really work properly yet. It doesn't have enough sources on the internet to come up with a valid solution. So I'd rather just write it myself, learn while I'm doing it anyway. I mean, there's pros to it, there's cons to it, but that's how I want to handle it. Okay, so we got this all set up. Yeah, exactly. AI is just helper, even though I don't like actually using it, because it kind of just forces you, well, it's not forcing you, but it kind of just makes you a little bit more lazy. I'd rather have to look up through a couple of internet pages to find the answer than rather just let AI give me the answer, because I will retain that information a lot longer than just having AI explain it to me. Okay, so this we can actually do in a function call. So we're gonna do a function call here that takes the render command list, and we're gonna call it, it's gonna not here, okay, and then we're gonna call it void initialize set root data. No, actually we can do it differently. We don't need to do this. We can just make sure we can get these. Okay. This is where it gets tricky. So in the render command, we have a reset and a finish. After the reset, we can also actually already fill in the root data, because we're gonna have to do this every single time. So from the render API, which is this file, we need to do all of these things. So we're gonna copy that over to here, and then inside this, we're gonna do set that, set that, set that. But we don't have these things, so we need to get these from our render API. So we're gonna say render API to get root signature. Wow, see, this is AI and that's doing it good, but not all of it is that good. So we're gonna give root signature here. Where's our root signature? This one. Boop, enter get root signature const, and then we're gonna return root signature dot get raw. Can we do that? Oh, const. What's this? Don't we have a const pointer? Let's also make a const one. That makes more sense. Still doesn't work? Eesh. I thought this was gonna work. Maybe it's this one that's annoying now? No. Ah, well, if we don't need this, it's fine. Oh, no, I know what the issue is. This needs to be const as well. And then we can probably call it. Yeah, there we go. Whew, I need to go to sleep. It's quite late in my part of the world, but I want this to succeed and you seem like a nice dude. You have a Discord I could join and follow you? Yeah, there's a Discord link in the description. It's very bare bones at the minute. But you can join that. I stream this time every single week. So if you want to join next week, that would be greatly appreciated. I hope you had fun. Thank you for stopping by. And maybe I'll see you in the future. Okay, root signature done. So the render command list should have this now. Only issue is I thought this was gonna happen. We can't have it const. So all that shenanigans I did to make this const and this const, we can't have it const because of course we can't. Okay, so let's do that, delete this. We don't actually need this function anymore. Okay, try, thank you. Oh, that's greatly appreciated. Okay, get raw, this is all working. Root signature done. Viewport and syserect. This is actually gonna be fill in root signature. This is gonna come from the render view, so we're actually gonna make a new function for that, which is gonna be set render target. So we're gonna do that, and then we're gonna make no, this, not this. Actually, do I have submit? Oh, I could do it differently. Oh, I have a clever idea. Anyway, render command list. No, we can't do it that way. Wait, can we? No, we can't. Okay, this is all fine. We're gonna, next thing we're gonna do also. I'm gonna do also. So, there's a lot of words to say. We're gonna finally also add a new function in here, which will be virtual void set render target. I can't type. Equals 0. Okay. At the moment, this is gonna be a little bit sketchy of how we're gonna do it, but we're gonna do it anyway. Basically, this probably needs to have like a function in here, a render target in here, but I don't have the class for it yet, so we're not gonna worry about that. But what we're gonna do is already make the function here. So I'm gonna make a void set render target override, and then we're gonna also implement it. Can I do that? Nope. So this way, and then void set render target. No. You. Bah. Bah. How am I gonna do that? Choose kickoff of completion. I don't want you to do anything. I want you to be an arrow. That makes more sense. So target, and then I can do tap to complete it. Okay. Whew. Man, switching to the new version of Writer gives a lot of anxiety. Okay, what did I have in here? Okay, the rectangles. Okay. Now we're also gonna do the last one, which is, so we got all of these figured out. Okay, so we got, this is already done, but we also need to set the render targets. And to do that, we need a barrier. So we're gonna yoink all of this code. for now. And then we're gonna do render command lists to that. It's gonna be tricky to do. Okay, so the command list we do have, so we can do that and that. This, not sure. The resource barrier, that's fine, but also the resource we still need to get. So we need to get current render target index. Oh, what we could do is get the handle and the, yeah, okay. So we're gonna make on the render API a function here, which is gonna be a void function, which is weird maybe, but it's gonna be get current render target. And for now, it's gonna take whatever this is, render target, so a resource pointer. Render target, and then also gonna take a handle, this one. Where did I make that function? Here. Render target view handle. Also, you know. Okay, and then why are you not included? I'll enter. Include. Which included it at? X12 command list. Oh, I don't need that one. Probably this one then. Maybe. Oh, wrong one. You. Yeah, it's the only one I don't have included yet. Great. Okay. So we're gonna have to implement that function now. So if you go back to this, and then at the bottom of this file, we are gonna include get render target. Okay, so what is this gonna do? It's gonna give us back all the things we need, which should be this. Oh my god, I'm making this so difficult for myself. So we're gonna say render target equals this, and then RTV handle equals, and then we're gonna just find it in here, I think. Did we not just, oh, we already moved it. Sure, this, and then back into hue at the bottom here, boom. Boom. Oh, there we go. And we're gonna move it out by reference. Oops. There we go. What I'm doing here is I need two output variables. It's a pointer, it's output. Oh, okay. Right here. I don't know if I actually need the barrier for that yet. We'll see if it gives issues, I guess. Okay, but then actually we can, oh, we still need to fix that, but we can also say whatever this was. Okay, let's do this. pointer and then RTV handle, right? And then we're gonna call Mearendipity dot get current render target with those things filled in. Handle. And that means, yeah, I know it might be uninitialized. That's the whole point. Equals no pointer. There we go. Oh boy. Okay, it stops complaining now. So we're gonna make a barrier on this resource to render target. And we're gonna set the render targets. Okay. I think that's okay. We're gonna optimize this later on. And we're gonna do the same here. Because you need a viewport and a scissor rectangle. Which, if I remember correctly, is just... Oh, I can also do this. We will have to optimize it a little bit later on. This is fine for now. Right. And then this will be later on as well. Populate, and then where is it? Where is it? What am I looking for? Oh, the almost. No, those triangle meshes. Oh, not you either. Why is there so much space here? Okay. Almost. Where is it? Where is it? My precious. These two. Which is the width and height. Do we need these for anything? Doesn't look like it. Interesting. Yeah, they make sense. So for now, I think I'm just gonna yoink these two variables. Yoink. And then move them over to the render command list this function and just do that. Oh, we don't have a width and a height. Okay, never mind. We're gonna go back. That was stupid. So we're just gonna get bounds or something. Same as this. Viewport and the rectangle. And scissor. And we're gonna say get target bounds. Which makes sense to me. And then go to this function. And then we're gonna do void get render target bounds. There we go. And we're gonna say viewport. Actually, why make it this difficult if we can just do... No, actually, this is fine. And scissor equals scissor brackets. There we go. And inside the render command list, we can do the same thing here. So I think I still have it saved. These two. Viewport. Delete all of that. Scissor, like so. And then we're gonna do render API. dot get render target bounds viewport and scissor. And then fill them in, of course. Whew, okay. That's a little bit tricky. We also need to somehow release the barrier at some point. So that's gonna be tricky to do as well. Oof. But this is already cleaning it up a little bit nicer, right? And then this is gonna be the interesting part. So this is the add mesh we're gonna do to the command list. So basically we can already do this. So if we go to application, we can already say m.render command list to, what do we have? We have set render targets. And then we're gonna make the mesh here. Render command list dot set shader. And then m.render command list dot draw mesh. That's basically the flow we're gonna have. And then we're also gonna have to clear the render target again. I'm gonna do release render target. Let's make the release render target first, because we can already do that one. So inside this one, actually it's not gonna be like that. It's fine, it's fine. Okay. We're gonna clean this up. Well, we're gonna refactor this a little bit later on, because once we actually have a render target class, we won't need to do this here. We will just directly call it with a resource barrier. So then we can just say add resource barrier on the render target and release resource barrier on the render target. It will be way easier than this whole crap. But yeah, we're gonna do this. We're gonna do release render target, and then we're also going to implement the release function here. There we go. And what do we need to do? Well, very simply, we need to do this render barrier. Yoink. So luckily we only have one render target at the moment, so we can do the same thing, right? And then it's gonna be a resource barrier here and render command list add resource barrier, and this is gonna transition it back to a present state or release state or whatever. Okay, I'm happy that we're getting close to an actual working state again. Only thing we need to fix is these, which is our draw indexed. Set PSO is set shader, and this is all draw indexed. It's the only thing we need to fix. Oh, we still have the fence and things to do, but that's cleanup we will do in a second. So, what did we already do actually? We have all of these. But it's not that. Okay, never mind. Can't release anything yet. We will make a set shader first. And we already have a shader class, so we can already do this the correct way. Render shader. Will it be a pointer? No, it won't be a pointer, so let's add an include. That's the correct one. Oh, we don't need it in here, no. we need to do this exact same thing in this class, which already has a shader. Oh, it has load shader as a pointer. Okay, so set shader will also be no wait, it's this one. Okay, this one doesn't have anything yet. Virtual void set shader equals 0, and then we're gonna include you. Alt, no. Oh, I'm gonna include it myself then. Oops. Clicking all the wrong buttons. Just did that 3 times in a row now. Include. And then we're gonna do shader. Shader. What are you complaining about? Oh, it has to be a pointer. It has to be a pointer. Never mind. We don't need to include shader. We just need to pre-declare it. That's nicer, actually. Class shader. There we go. And then in here, we actually need to do pointer. And then inside our render command list, we're gonna do void set shader. Which is gonna be render command list dot. I don't have a set shader on this. What's the call? Set piezo shader dot get pipeline state. Oh yeah, we need to same thing we did in the load, I think. So we have a load here somewhere. Where's the load shader? This is the load shader, right? What does this do? It makes a piezo, right? And it saves the piezo. Yeah, but we need to cast it to a DirectX 12 shader. I do like my namespaces, so I'm gonna add the namespace to it. Shader, and then we can do DirectX shader dot get pipeline states. Don't we have a get pipeline state? Or whatever it was. Oh, we only have a set piezo. We don't have a get piezo. Sure, get piezo. And we're gonna return pipeline state pointer. Don't do anything here, and then we're gonna do that, and we're gonna say return pipeline state objects dot get raw. Apparently, yeah. And then inside the render command list, I'm gonna do get piezo. Done. All we need to do for set shader. It's great, isn't it? And this means that now inside our application, we load the shader somewhere. I'm not sure where we load the shader. Oh, we do load shader. Why do we do it in here though? Can't we just call load on the shader? Shift 12, nope, okay, never mind. Navigation's not that great. Why do we do that in here? Because we need the root signature, is that it? Oh, and the M device. Okay, no, this makes sense. We should just call create shader. Oh no, but we don't want to load it directly. So we can do create shader. We can do the same hacky thing, but we'll make sure that works eventually. I don't like that we need to load it there. Okay, but then we can actually do set shader to shader. mesh.get. Okay, getting close. So now we just need to do the mesh, and we have a working, hopefully working, we actually don't know yet, hopefully working prototype again. So set piezo, done, right? Bush complete. We still need to do this, which is our vertex buffer view, which we make somewhere like here-ish. There it is. Which is all of this crap. And I was gonna throw it in a file as one would. But what if, just for shits and giggles, we keep all of that here and we're just gonna call command list to submit dot add mesh, and then we do this. I'm not sure. Okay, I want to just make sure that it works, so we're gonna copy this. Oh shoot. We're gonna copy this. No, wait. Oh no. Okay, let's do it a little bit weird. So in the render commands, we will add our void.add shader, add mesh, draw mesh. Oh, no, apparently I've not made the function yet, so let's do that and then do draw mesh. What did I call it? Yeah, draw mesh. So inside view first, draw mesh, and for now, because we don't have our mesh object yet, it's gonna be empty. That's a render command buffer. This one done. We have draw mesh. This done. Render command list. Draw mesh. This one. It's gonna do this. Only thing we don't have is this vertex buffer view, just so we're gonna just get that from our DirectX 12 render API at the moment. So we're gonna do, because I'm gonna just hack it. By reference, please. Get vertex buffer view. Buffer view, control right. There we go. Control right. Right. Const. And then we're gonna do return for. Oh my god. I don't want a const. Okay, and then in the render command list, we're gonna just do m render API dot get vertex buffer view. There we go, and that should work. It gets my pointer. Okay, well, what am I building? Well, hold on for 1 second. I think I can actually build this and show you, but we're making a game engine. But I think, hopefully, you just joined me at the point where okay, never mind. There are some errors, but you just joined me at the point where there's actually some. Oh, there's more error warnings I need to ignore. Okay, so populate render command. This function doesn't exist. I'm like a minute or two away from actually working this out and submitting it. So render API and basically running it. So what did I miss here? Where is that included? It's in DirectX 12 render API, but which file specifically? Which file is it complaining about? Random DirectX 12 state thingy. Oh god. Oh, apparently I don't need shade. No, I do need shade. Why do I not need shader? No, I do need shader. I'm watching it should work. Yeah, well, that's it would be nice if it worked, right? See declaration of this? No. So now I'm hunting for one where we don't have this error enabled. So this one does have it. This one should not have anything in there. I don't know why that's implemented. Okay, this one doesn't have it. That's Windows, that doesn't matter. So you have the error. Do you have it? You don't have anything included. I don't need shader in here. Do you have it? You have it. This is quality content. Oh, it's this one. Okay. So let's just copy all of these because it's for the same file. Paste them in here. This one we already have. 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 And these two are new. Oh boy. Build. Please work. Oh. Okay, I passed that file. It's passing our render API. It's building our engine core. So close, there's one file left. Unresolved external symbols, oh god. Which file did I forget to? That's public void render API void. Oh. Yeah. Equals default. There we go. And that should now work. It's just missing a default constructor, I think. Because I call it directly. Okay, render API is compiling, engine core is compiling. Application compiled. It compiled. Okay, let's see if it actually still works. What should happen is we shouldn't get an error. That's bad, but basically we should get a triangle on the screen, which, I mean, why is it? Okay, so I'm gonna have to look at the stack. Swap chain present is failing. Do we have any more information? Oh, wait. Oh, we have some interesting errors here. Resource barrier, no pointer specified, resource manipulation error. Okay, so a resource barrier is failing at some point. Okay, this is interesting. So let's put a breakpoint in our... So this is a render. So we submit it here. So let's check our application first, because this is where we write everything, right? Right? Yes, this. So we set a render target. This is probably where it messes up. So let's retry that. Stop and rerun. Okay, so we got in there. So okay, we got the pointer. We go inside here. What the hell is this? Just get out of there. Oh, what? Just what? I don't know what this is doing here. Can I close it? No, I can't. Okay, just disappear to my other screen then and don't worry about it. Okay, so we get the viewport and this is a rectangle, which is correct. Set this. We still didn't get any debug log here yet, right? Yeah. Set that. Still no debug log. Get that. Still no debug log, right? Yes. Oh no, you missed it. Oh, anyway, good luck with the computer networks exam. Yeah, well, I will solve it. Just because you joined stream, I will have solved it. We get all of these. That's still fine. Okay, so render target is apparently a null pointer. So why is it a null pointer? Render target's not initialized, maybe? When does this happen? It's load assets, right? Oh. Eesh. Okay, so it's a null pointer. That makes sense. Do not show. Yes. Retry. Okay, so get the pointer. Set the render targets. Get the current ones. Render targets. Come on, render targets. Okay, so they have both a pointer on the frame index, which is 0. So RT is now, hopefully, a valid value. Okay. Get the resource descriptor handle. Should also be valid handle. It's a pointer to something, yeah. When the target value is still assigned. This is a valid value. Why is this not? Why is this? Oh. It should be a resource, and then this should be the reference to the resource. Like so. Maybe, but I can't make that. Huh? No, this should just be a pointer by reference. Oh, that's gonna be that awkward syntax, isn't it? F12, it's gonna be a double pointer. So we can also do this. That's just gonna look weird, but it will work. Oh, this is, I mean, we're gonna fix this anyway, sooner or later, but this is, I mean, this syntax is horrible. It should work now. So, we should see if we go and, oh, it's compiling again. Okay, compiled. So we got there, and then we're gonna do this. Wait, did we get any errors? We did not, so we can still keep going. Solved it! We have our triangle back. Oh my god. Good. 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 We still can, it still works. Oh boy, that took so long. Jesus. Okay. We got all of this worked. But that does mean we can scrap this. Oh, we don't have the add barrier. And we don't. Let's leave that for when we actually make the barrier class. So let's yoink this. And after we create the barrier boss, we do that. Submit command list we did. Even though it's not correct or 100% correct yet. Okay. Boy. So happy though. Happy we still got the. Did I remove my breakpoint? Yeah, I did. We got a triangle. It's insane. Oh my god. Oh boy. Oh, that's weird. Okay. What to do next though? So what we need to do now is actually set render target. How I'm doing it now is if we go to a render command list. I'm basically doing a lot of crap in here that should be in a separate class. Like set render target, we should just pass it a render target itself, so actually a class. It will get the viewport for it, it will get the scissor rectangle for it, and it will set that up. It will get all of this from the render API as well. Well, it will probably already have this stored somewhere, right? And then the barrier we need a class for. Actually, that might be the easiest one to actually make a thingy for. Is to create barrier on that resource, and then do an add barrier, right? because I'm pretty sure these have like, does it show what this has? Barrier. Yeah, it can have a transition barrier, UAV, aliasing barrier. There's a couple that you can have. Oops, that's the wrong button. Right, it's basically all of these. Wherever this is defined, probably all the rest are here as well, yeah. So transition, aliasing, and UAV. And then you can probably switch states as well. So we need to create these barriers. Will that be the easiest? I'm not sure. Also clearing it always, bad. Right, we don't want to. We basically only want to do this when we request it as well. Basically the only correct line is here. What am I making? Well, let me show you what I'm making. I'm making a game engine, and at the current state, it looks like this. It's a triangle, but it's a very complicated triangle. I'm setting up everything, even though we have only like a triangle to draw. I'm setting up everything correctly as how I would want the game engine to be set up. So we have a full rendering API where I can say like, wait, let's go just to the application. Let's go through all of the things, right? So we have a game loop, even though it's simple and it's just with a temporary bottleneck that's already set up, and we can expand it in the future. Game loop, what the only thing we'll do is handle window events and render. We don't have an update loop yet because we're not changing anything. That will be next step after the render API. And then for the render, what we do is we have a full render API set up with the render command list. Whoa, I did something weird there. Where we can set render targets, shaders, draw meshes, and then actually render the whole thing. So it's the bare bones of a graphics engine, let's put it that way. But it has to turn into a game engine eventually. So that means graphics, physics, and gameplay. And then of course sound and animations and whatever else is involved as well. But for now, it's just a triangle. But we're using that triangle to set up the correct structure. I mean, you can see it on all the side projects I have as well. I have more than one. But yeah. Okay. Don't like the temporary bottleneck either. We still have the mesh class to do as well. So much stuff to do. Okay, so what would be the next wise thing to do? Let's actually check what I set. I think my next step was gonna be the render target class, which makes sense. So you make one render target because we're only drawing to one now, which will be the main render target. So we're just gonna call it main RT. We're gonna have the application manage it, I think, right? So we're just gonna make a render target here. I heard triangles. Wanna see triangles? Well, triangles is optimistic. How about one single triangle? That's how far we go. Which language is the easiest? C++ or C#? Definitely C#. The way I look at it, C# is just C++, but with guide rails, with all the edges just softened, made it basically baby-proof. It's heat mapped. It's not really heat mapped. It just has a color per vertex, which interpolates because my shader does that. But I mean, that's just a basic graphics shader. I'm deciding what to do next. I do want to make a render target, I think, and then we'll have a create. Only thing we're gonna have to do is just get it. I don't think. Oh, and we can set the width and the height of it, and the size and the resistance rectangle. Yeah. And then the render target. Well, the render target have the command queue. That's also actually a good idea. Have the render target have it, because you're doing render commands for that render target, so that kind of makes sense. But technically, we can also have multiple render targets in there. So many choices. Let's see. I am happy that I got it to the working state though. Let's actually put it up once more. It's nice. Yeah, so triangle. Okay, so because basically this whole thing, we only have one render target at the moment. We only do one render pass, so it doesn't make sense for anything else. The application is definitely going to manage that render target at the moment, and then we will draw to it, so that makes sense that the command list... No, let's keep the command list separate and then specify that we draw to that one. So you have just one main command list, one render target, and they will just use each other. I think that makes the most sense in this case at the moment. This might all change whenever I implement like deferred rendering or something. But for now, it's simple for rendering. It's not even a 3D yet. We're gonna worry about that in the future. What package or graphics engine are you using? I'm using DirectX 12. And that's the only thing I'm using. It's bare bones C++ basically, with only access to the operating system. So we just have the Windows API and DirectX 12. Because I need something to manage the operating system, I can't go around that, and I need something to actually draw to the screen, and DirectX 12 is the easiest way to do that. Well, not the easiest way to do that, but the most, let's say, low-level way of doing it. So, render target class. Again, how are we gonna do this? Well, I've had this before, but we're gonna go back to the CMake list. We are going to make an interface, so we're gonna make a render target interface. There we go. We're gonna order it correctly, and then inside our DirectX folder we're gonna add the render target one. So we're gonna do this, copy that, put it in here, that, and then also have the CPP. And this is bothering me, so let's just do that. Yeah, we need to create those files on disk as well, unfortunately. Well, let's just copy the shader file for now, and let's call it render targets. .h, copy paste that one, render targets .cpp. Yes, I'm changing it, and then inside our normal render API, which is our interface, I opened the file. We're also gonna have render target.h, and yes, I want to change the file name. Okay, rebuild. Rebuild selected projects. You had a question. Nice. When I took over computer graphics, I used OpenGL and C++. It was a catalyst that got me into 3D modeling and animation. Yeah, OpenGL is a very good library to use. It's a lot easier than using DirectX 12 because again, it has a lot more wrapped and not abstracted, so it's a lot more user-friendly. But I want to have a challenge, and eventually I want to make it like platform specific, and having one that's only specific for Windows will help with that. Well, I want to make it platform independent, but this one is specifically for Windows, which means it's optimized for Windows. And then if I want to extend it to another platform, I just add another render API, implement everything again. Well, I'm moving, and then we're golden. Which is why I spent so much time abstracting everything into like a DirectX folder, Windows 32 folder, and have the API, which is what we're gonna do next. Oh my god, that was a bit of lag. Okay, so this one is gonna be the normal shader, so this should not have anything in here. This is gonna be render target. It's gonna be an interface, so it's not gonna be final. It's not gonna inherit from anything. It's gonna have a public render target function, which is gonna be default. And then it's gonna have that, this here, virtual, the normal stuff, and we don't need anything in here yet. I don't think if we ever will have anything. Oh, we might have already set the window width. We might just set up the width and the height in this thing. That might be a good one. think so. Yeah. Okay. This needs to be included, so I'll enter that one. There we go. It's nice and purple now. I like that color. Why are you padding size of HP render target with 8 bytes, 209 boundary? Why? Just shut up. We don't need any of that. I'm not checking any optimizations yet. Okay, and then our render target in here. What do we need? Nothing in here yet. First of all, let's also CPP, just delete everything and then just include the main file. There we go. Should find a better way of doing that. This one, only thing we need to do is include what's it called? Just render target. This one, and it's the one we're gonna do in here. Also, I'd like to have my namespaces. Final, and then we're gonna call it DirectX 12 render target. So like so. Copy this, paste it, paste it. We don't have anything in here yet. Paste it here. And this can also be empty. Whew. And if I did everything correctly, it should still compile. There we go, it does. Great. Oh boy. I am curious though. Let's actually do a little test. What if we do rebuild solution? How long does it take? So CMake was immediately done, which is weird. And then these files start to take a while. Yeah, it takes 13 seconds. That's insane. That's very long. I know why. I do know why. All these files take a long time. Yeah. Which is all the Windows source code and the DirectX source code. And we want to actually only include that once, but fuck it. It's fine. Okay. So we do have our render targets now. So what do we actually need to abstract? Well, if we go to our render API or implement it, cancel render API, we have a list of render targets, which is fine. We basically don't want to keep track here, which is gonna be weird because we need some kind of authority that manages it. Because we use 2 render targets, right? We have a frame buffer. I have some tricks to speed up the compilation, don't worry about it. Mainly why it's slow is because we have these. We have includes to DirectX 12 and includes to Windows, which are even worse, inside header files. Not in this one apparently, but this one. We have all of these. Ugh, ugly, bad. Same here. No, this one is actually fine. Why do we have memory in here? Don't get out of here. Okay. And the reason they are slow is because a header file can be included multiple times, and every time we do that, we will try and include that file again, which will compile it again, which will be slow. And since it's always included in like a CPP file, this is recompiling that whole thing. We don't want that. We basically only want those in our CPP file, which we can do. I don't want to do it, but we can do it very easily if we pimple them. And that's what I'm gonna do eventually, which is moving this whole thing actually to the CPP file and having the interface have a member which is called p implementation, which is a pointer to itself. And then we can do some weird stuff with that. The only issue there is, well, I don't have this I can't add more functions to this, right? So I like this way better, but it is a little bit slower to compile. But if it ever gets an issue, I know how to get around it. Yeah, okay. Where was I? Render target. Yes, we're checking out the render target. So this issue I have is that we're gonna have to make another object that manages it, because we have multiple render targets, right? We make 2 if my count is correct. So let's see, where's the render targets? Render targets. This is the swap chain. Okay, so we make this, or the descriptor heap. And this one will count 2 descriptors, which means it will have 2 render targets. And then we're gonna create 2 of them here, right? So this is all of our render target views in a descriptor heap. Technically, we don't need to do this, I guess, but I think we still want to we want to have as little descriptor heaps as possible. Pretty sure that's the idea here. Actually, I'm not sure. What does this, when do we use this handle? So we use it there, we use it there. Do we use it anywhere else? I mean, I do know we use it at the bottom here just to get the handle. So is it an issue if we only have one thing in our descriptor heap? Because if that's the case, we don't need any management. We just, we still need to swap it, right? So we need to put on the swap chain somewhere. Oh, this is gonna be crazy difficult. So yeah, I want to keep this, but I also want to make the list have 2 render targets. And then I'll need to swap between them. Interesting. How does one do that? We're getting to the end of my knowledge again. I mean, we could have like some kind of wrapper around it that will manage like the buffering. And then we just create one of those objects and it will have just a render target and we can get current one. That kind of works, right? That will also have the render API. It's basically like I call it a frame buffer. But I don't want the render API to store these, right? Actually, we could have them store it and then we still can do the get current one. Actually, how we do it now is fine-ish. No, it's not. Hello, hi there. Welcome to the stream. Trying to make a game engine over here. Okay, so what I want to do is for the application to have the render target it's drawing to. But because we're double buffering, because we can't present and draw to the same one at the same time. So we have 2 of them, one that we show to the player and one that we work on in the background, and once that's done we swap them. So we have 2 render targets, but I don't want to keep track of a list of render targets. I just want to keep track of like swap chain is a good way of calling it, I guess, but it's not really a swap chain. It's basically a frame buffer or a render target buffer. We could call it a frame buffer. Let's see if we actually have some help from DirectX 12 on this. Frame buffer? And access to general fields to the back before the swap changes as a final compass. Yes, yes. Okay, actually. So I had the name incorrect. To prevent memory corruption. Yes, swap change and buffers. To allow render parameter to draw back the buffer, you must bind a render target view and memory location. Yeah, we don't need about that. Under a component. Okay, so there is some views if you want. I can provide. I don't want AI. Hey, what is fun in watching a coding stream? Hey, well, you joined it, so you tell me. Okay, so this is a basic graphics pipeline. This is the one I use to actually set up everything. So yeah, this is gonna make a back buffer, but it's not doing it in a abstracted way, right? So it does have this render targets list, which is the one I'm trying to avoid. Well, make a generalized object for it. So I could make like a frame buffer and set the buffering and actually make it generic, so we can make it with triple buffering if we really want to. How to start building projects from scratch without using AI? Well, very simply put, it's a lot of Googling. you can see me looking up stuff right at the moment now as well. There's a lot of useful guides out there, and I mean, it's basically dedication. I know I'm not gonna do everything correctly the first time, but in between all of these streams, I go and look things up I didn't know beforehand. I do need a shader. I'm making one, like right here. Shut up. I need this. I know this is in here, but I don't... shh. I'm correct. Okay, so yeah. Also, you should be at the bottom. Why are you at the top? It's just a naming convention thing, or just a style thing. Okay, so I think what I'm gonna settle on is making a generic frame buffer struct or class, where we can specify how many render targets we want, so we can double buffer or even triple buffer if we want. I don't know why we would triple buffer, but it's possible. Well, technically we can triple buffer if we already want to draw to the next one. So then we will create a render target view with 3 trip buffers with 3 command lists, because we have one per render target as well. Yeah, something like that. And then we can just rotate them as long as we want. Okay. Do we do that now? I think so. Or do we... No, we're gonna do the old-fashioned way of doing things, and that's just keeping it in render API at the moment. So instead of already putting this in a frame buffer, what we're gonna do is we're gonna make not a unique pointer. No, this is gonna be... No, it's not gonna be that unique pointer. It's gonna be a normal unique pointer. Buffers are, yes, it's just an allocated block of memory. But basically what a frame buffer is gonna do is, I explained this like a minute ago, but I think you just joined a little bit. I mean, let's put it this way. When you, let's get on the application. So let's explain it this way. We have our application right here. If it boots up, it's compiling. So for rendering, it's a bit different. Basically, you're creating a buffer for the memory of your screen, right? And in that buffer, you're gonna put all of the information of how to draw the pixels. How big that buffer is, DirectX 12 manages it. The issue is, while we are presenting one buffer, we cannot keep writing into it because you would see all the gradual updates to it. So to go around that problem, we most of the time use 2 buffers. One that we present to the player, and then one where we can do all of our graphics rendering stuff on in the background which is already basically the next frame in your game, you're gonna gradually increase that, make it, build it up how you want. Once that is fully complete, you swap the two buffers, so you get the new frame presented, which is just again another block of memory, and then the old frame you can clear, draw to whatever you want. So we are seeing one frame here, but in the background it's actually using another frame and then constantly swapping those two. And that's why we have a list here of render targets. We have, I think it's 2. But I want to make it scalable, so in the future if you have 3, which is possible by the way, because while we are showing one frame we can already make the next one, and then if you have time left you can already start on the next one, but maybe something else needs to like release some resource or something before you can swap. So it makes sense to have like a sort of queue of next frames to work on. But I'm not gonna do that yet. First of all, I'm gonna make the concept of a render target. So how to do that is, instead of having this here, you're gonna make a render target, this one, and we're gonna forward declare it, because oops, I actually used the wrong one. We need to put that in there, and this is just gonna be a unique pointer of render targets. There we go, with frame count. And now to actually implement it, we can already see this is all broken now. And this one is also going to be broken. Yes. So render target, we don't need to do this. We can just do get. And then we're not going to return the resource, but we're going to return the render targets. How many frames per second? Well, the engine itself does not define how fast your game is going to run. So frames per second for an engine side doesn't matter. However, it is the game loop. I'll show you in a second. Let me just find this out. It is the game loop that decides how fast the game can run. And if you are gonna take a look at my game loop in a second, let me just fix this really quick. And I also want the namespace in here because I like namespaces. Okay, so if you're gonna take a look at the application class here, what I'm doing is I'm basically throttling my whole game. So this is what we call a capped frame rate. At the moment I just put an arbitrary value in here, but what we can do is say like, hey, I want my game to be capped at a 30 frames per second, so we put like a sleep at the end of every single frame that will make sure that we hit that frame rate. So it's basically slowing down your engine. That's always possible. If you just let it run free, then whatever frame rate your game's update loop happens at is the frame it's going to run at. So it's basically purely dependent on what game you're making, what scale you're making, and how you're optimizing, how fast you want to run it. Most games want to run at 60 FPS these days, or even faster, especially if it's like first-person shooters, they want to run faster. But it's not the actual game engine itself that's deciding that. It should be up for the game. Because based on what game you want to make, you want to do different things. If you're gonna make like a very complex multiplayer game, you maybe even want to run in some kind of lockstep, so you want to have a capped frame rate so that you can easily sync between your players, because you know they're gonna run at the same exact frame rate and you don't need to do any calculations to account for that. But to actually answer your questions, the games I want to make, I want to at least make them run at 60 FPS. So it's a long-winded way of saying it actually doesn't matter, but if it does matter, it's 60 FPS. Okay, so we put the render target in here. This is still fine, right? We got the frame index, we got the get. For this thing, we don't actually need anything, so that's also fine. So this one we fixed up, but we still need to fix that in our render command list, because this will do set render targets. which will try and get a render target now. And then I should do rt.getResource. But I don't think I can do that without converting it yet again to something else. So we can actually, would we be able to do something a little bit sketchy? Let's see if we can actually do it sketchy and if it would complain. If we can do 12 render targets. And we're gonna include that. And it might complain, and I think it will complain. It does complain. Yeah, that's what I thought it was gonna do. Okay, so we're gonna put our DirectX 12 render target there, and then make a normal render target. Oh, this is a little bit silly, but we'll fix that eventually. Okay. I close it. Oh, I made it smaller. Okay, so yeah. Press Alt this time. Okay, so is static cost. There we go. Of DirectX 12. There we go. Isn't it? It's control. Okay, and then namespace, because I'm silly like that. Boop. And then I want the DirectX 12 render targets. .get resource. And inside the DirectX 12 render target, we can already add that get resource function here. So basically, we're gonna make a private. Please clean my 35. What does that even mean? Oh. Okay. Yada. This is ugly. Okay. We need a variable. What variable was it gonna be? It's gonna be the render target resource. Yes. Well, is it the resource? Yes, it has to be the resource, isn't it? Yeah. Okay. Yeah. Issue found. But we're not gonna let it deter us for now. We're just gonna, oh, I removed whatever this was, so I don't remember what it was. Yeah, let's just that. Yeah. Okay. So, what was I doing? Oh yeah, we were making a resource. I don't remember what it's called. Diary 12 resource. It has to be something like that. I can see it here. ID. Okay. I was so close. And then this is in oh no, it's in one of these. So let's just copy this block, put it here, and okay, we don't need these yet, so delete it for now. And we're gonna make this again an HB render DirectX 12 unique pointer of this type. I'm gonna call it M render target resource. There we go. And then inside the public, we're gonna make this return a pointer get resource, which will return M resource like so. Oh, pointer, yeah. So dot get raw. There we go. That's all done. Okay, and then the, what was it? Render command lists should get resource. There we go. Done. Anything else? Get current. Oh, we have the same issue here. So again, copy that there, paste it here, convert it to a DirectX 12 one. Don't think we need it. Oh no, we do need it. And then on a DirectX 12 one, dot get resource. It's a little bit like winded, but eventually we will pass this here, right? We will pass this pointer in here. So we will only need to do this and not worry about all of this. So that's all fine. That's okay. That's how I want it. So that's all done. So now it's just the render API left to fix, I think. Yeah, these two. Where we actually make it. Oh, my glass is empty. Okay. So we need to set the resource. So how we're gonna do that is we are going to do... Oh, yeah, we're gonna make it very easy. We have already made like all of these things, right? Create render command list, same thing, create render targets. And it's gonna be an override, so let's copy this. Put it inside our interface as well. Not this one, this one. This one. Virtual. Render target equals 0. There we go. We also need to include this, but we can do render target. I don't know why render command list is in here. It shouldn't be. And then we do render command list as well. It's gonna speed up compile time a little bit. And then we still need to implement it. So inside here, we will, at the bottom, where do I create the others? Okay, so here, in between here, gonna type void create render targets. Yes, there we go. Automatically adds the function. And this is where we are going to do all of this crap. Well, no, we're just gonna do this crap. Copy this. Paste it in here. Oh, we need to give it a handle. Oh no. That's gonna be tricky. How we're gonna do that? I'm not sure. Interesting. So we need to give it some space to work with. Huh. I need to look up what the descriptor heap. If there's any downside at not putting them all together. I looked this function up a lot apparently. Pointed to a structure that scraps the heap. Okay, let's also open this up. Can be obtained? Yeah, examples. Yeah, I know, but does it matter if we just put a descriptor heap at 1? Okay, so direct x12, descriptor heap size 1. A it doesn't say. You can set the limit, but doing so causes massive performance bottlenecks. Okay, so we're gonna have to request an index, I guess. Oh, it's gonna be that bad. A set descriptor heap call is expensive for render targets. And this is back to, however, since most rendering on swap chain multiple back buffers, a heap size of one requires you to recreate and rebind every frame. Oh! Where do we bind this thing though? Hold a second, hold the phone. Get buffer. We get a buffer on the swap chain for the ranked targets. Huh? Yeah, but where do we set the heap? We never used the heap, right? We just set it here. It's for a descriptor handle. Find this. Yeah. Create a handle. We created the heap on the device though. I never had to bind it. Huh? I don't get this. Okay, the purpose of hit synchronization. Do I just call set descriptor heap somewhere? Oh, maybe in the root signature. No, the root signature is empty, right? Find. It's only used once. I'm confused. Just be starting. What does this do? Because I don't call it. This is on the command list, yeah. I'm confused. Again. We never did this. Oof. This should point it correct. I don't get it. Do we need to bind them for render targets? Because I'm not doing that. That's the whole, that's weird. Right? We just create that on the defines. Let's just do that. Descriptor here approach. Oh, it's not answered. It's great. Is the code not coding? No, the code is coding. I'm taking a look at how to actually use the descriptor heap, because I'm pretty sure we should set it on the resource view, but not for render targets apparently. Shader resource views, constant buffers, or another axis. Okay, render target. Descriptor heap can also be used for creating render targets. Yes. So we make it. Create render target view. Tab stencil view. And this is on a separate depth descriptor with only RT count. So a couple. So I think for render targets, I can just make a separate descriptor heap. I'm not sure if that will have any issue. I get it that for shaders we just, well, for textures we just put them all in one big heap. But what for the script? I'm confused. Because we just get a descriptor, right, on set render targets. What if this does not happen in the, I mean, aesthetics, exceptions? I mean, it's fine. It's telling me, like the AI is telling me, but I don't trust AI. It's telling me to not make one of size 1. And I tag a few descriptor heat size ones. Okay, is that size for one descriptor? No, creating the descriptor. There's no need for by calling set render and then it's total number of artificial is going to be much more than numbers used in the program. That is true. Okay. So I think after all this research, it means that for these, I mean, it makes sense to make a descriptor heap for all the render targets view or for have more than enough targets view. But I think for this, we can actually create a descriptor heap with just one. And then we don't need to worry about any of this. Right, we just make a heap on the render target. And I think that's fine. I think. However, it is getting late, so we'll do some research off stream and we'll try and implement it next week because I have run out of time. I have run out of water as well, like half an hour ago, so my mouth is super dry. This all being said, this was a lovely stream. thank you for all of you for joining. It is getting dark outside as well. Yeah, there is a link in the to my Discord in the description if you want to join that. Don't feel, I mean, I'm not, you're encouraged to join, let's put it that way, but I'm not forcing you to join in any way. Other than that, I stream this kind of thing, so working on this game engine every single Tuesday at around this time. If you, I mean, that's about all I have to say. We will continue next time working on this. Have a lovely rest of your day. I need to find the end stream button. I always forget that. There it is. And yeah, I'll hopefully see you next week. Goodbye. I missed the button. That's great. Let's try that again. Goodbye. Yeah, there we go. I hit it. I had to look at it though. Oh my god.